Hello friends, I welcome you in lecture number 12 on applications of integration. In this lecture we will discuss this question on finding volume of solid by washer method. This question was asked in GTU Winter 2018 exam. The question is find the volume of the solid obtained by rotating the region R enclosed by the curves y equal to x and y equal to x square about the line y equal to 2. Here axis of rotation is different from x axis and y axis. It is the line parallel to x axis. And we can first find out the intersecting points of these two curves. So for that we take y equal to x in this equation and we have x square equal to x, and after solving this we obtain x equal to 0 and 1, and because x and y are equal we can say that these two will intersect at 0 0 and 1 1. So now we try to sketch the region enclosed by these curves y equal to x and y equal to x square. So for that we first consider two-dimensional plane. Suppose this is x-axis and here we have y-axis. Suppose this much distance is 1. So this we consider this much distance as 1. This much distance we consider as 1. So this is 1.5 and we will have 2 somewhere here. So our line y equal to 2 is the line parallel to x-axis passing through this point. So this is the line y equal to 2 and our curves are intersecting at 0 0 and 1 1. So we consider this much distance as 1 on x-axis also. This is x-axis. Here I have y-axis. So this point is 1 1 and we have to consider the region enclosed by y equal to x and y equal to x square. We are familiar with the graph of y equal to x. It is the line passing through origin at 45 degree, and y equal to x square is the parabola which opens in upward direction. So our region will be this portion only, portion between 1 1 and 0 0. So here we sketch that much portion only. We are not sketching the whole graphs. So we consider the portion of the line between 0 0 and 1 1, and we consider the portion of the parabola between 0 0 and 1 1. So this is the parabola between 0 0 and 1 1. Okay, so this is fine. We just require rough sketch. Here we have y equal to x. Here we have y equal to x square. Axis of rotation is y equal to 2. So now we have to find out the volume of the solid which will be generated by rotating this region R about the line y equal to 2. So now every time we are sketching the solid generated by the plane region, and then we decide the cross section of the solid, and then we find out the outer radius and inner radius of the washer. But without sketching the three-dimensional solid also, we can decide what are the outer radius and inner radius of the cross section. So for that, again I repeat, the solid which will be generated by rotating this plane region about the line y equal to 2 will having a hole inside it. So the cross section of that solid perpendicular to axis of rotation will be a washer. So we can find out the outer radius and inner radius for that washer without sketching the three-dimensional solid also, from this plane region only. So for that, outer radius can be obtained by considering the distance between the axis of rotation and the curve which is farthest from the line y equal to 2. Here we are having two curves, y equal to x and y equal to x square. So we can see the distance of y equal to x square from y equal to 2 is more than the distance of y equal to 2 and y equal to x. So we consider the distance between this y equal to 2 and y equal to x square as the outer radius. So this will give me outer radius. So outer radius is the function of x, and it is nothing but distance between y equal to 2 and y equal to x square, that is 2 minus x square. Similarly, inner radius, this is r, that is outer radius of this washer, which is the cross section perpendicular to the solid, perpendicular to the axis of rotation. Cross section of the solid perpendicular to the axis of rotation. Similarly, we can find out the inner radius by considering the distance between the axis of rotation and this curve y equal to x, which is closest to the axis of rotation as compared to y equal to x square. So this is small r, and this small r is nothing but distance between y equal to 2 and y equal to x, that is 2 minus x. So in this way, without sketching the three-dimensional solid also, we can decide what are the outer radius and inner radius of the washer, which is the cross section of the solid generated parallel to the axis of rotation. And we can imagine that three-dimensional solid here. Suppose we just try to imagine the three-dimensional solid, then let me sketch somewhere here. X-axis is somewhere here, and this is the line, this is 1. So suppose this distance is y equal to 2, and our region is somewhere here, and we want to find out the solid generated by rotating this region with respect to the line y equal to 2. So first we take mirror image of this about the line y equal to 2, and we can see this is at distance 1. So we have to go up to 1 distance above the line y equal to 2, and mirror image will be this type of line segment for this. Similarly, mirror image of parabola may look like this. So this will be the solid which we will obtain by rotating the plane region about y equal to 2. And if we take cross section of this solid perpendicular to the axis of rotation, then cross section will be a washer. So this is the, suppose this is the cross section perpendicular to the axis of rotation, then cross section will be a washer. We may have this type of picture for the washer. This is inner circle, this is outer circle. And now we can see, if we want to find out the outer radius, we have to consider the distance from the center to this curve. So this distance from y equal to 2 to y equal to x square, that is going to be 2 minus x square, which we have written here. So this distance between y equal to 2 and y equal to x square is outer radius. So that we have obtained without sketching the solid in three-dimensional space. Similarly, distance between y equal to 2 and y equal to x, that is this much part, radius of this inner circle, that is the distance between y equal to x, and this is nothing but r equal to 2 minus x. So that we have written here. So in this way, it is not necessary that you should sketch the three-dimensional solid. Without sketching the three-dimensional solid also, we can decide the outer and inner radius for the washer, which is generated by rotating this region about the line y equal to 2. So now once we have outer radius and inner radius of the cross section, we can decide the volume, and because here both are functions of x, we have to integrate with respect to x, and we can see x lies between 0 and 1. So now volume of the solid generated by rotating that region is given by this formula. Volume of solid is v equal to pi times integral from x equal to 0 to 1 outer radius square, that is r of x, minus inner radius square, and integral with respect to x. So this is going to be pi x equal to 0 to 1 r of x, that is outer radius, 2 minus x square. So we consider square of 2 minus x square minus inner radius is 2 minus x. So we take 2 minus x whole square integral with respect to x. So this is equal to pi times integral from 0 to 1. First we expand this using the formula of a minus b square, that is 4 minus 2 into 2 into x square plus square of x square, that is x raised to 4, minus 4 minus 2 into 2 into x plus x square, and integral with respect to x. So now we can simplify all these terms. 4 we can cancel out. Here we have minus 4x square, and there will be minus x square from this, so that is minus 5 times x square, and plus x raised to 4, and here minus 4x into minus 1, that is plus 4 into x. Now integral is pi equal to minus 5 integral of x square is x cube by 3, integral of x raised to 4 is x raised to 5 by 5, plus 4 into x square by 2, 2 will cancel out, and limits of integral are from 0 to 1. So first we put x equal to 1, and we have minus 5 by 3 plus 1 by 5 plus 2. For x equal to 0 we will obtain 0. Now we take 15 LCM. So here I have to multiply this by 5, so we have minus 25, here 3 I have to multiply, and plus 15 into 2, that is 30. So I have 33 minus 25 divided by 15. 33 minus 25 is 8, so my answer is 8 pi divided by 15. So in this way we can determine the volume of the solid generated by rotating the region between two curves about the line which is different from x-axis and y-axis. So I hope you like this lecture. Thank you very much.